Thank you very much, Catherine. I think this is one of these topics that just opens probably a lot more questions than it just answered, but it's an area we have to focus on because the industry is evolving so fast. And from there, we move to our second case study, and it will be presented by Dr. Lydia Olander. She's the director of the Ecosystem Services Program at the Nicholas Institute for Environmental Policy Solutions at Duke University, and she's also Secretariat member of the Bridge Collaborative. And she will focus on the clean energy challenge. Lydia, please.
So I'm going to be looking at an aspect of this challenge. So we, of course, are talking about low carbon and clean energy, but the piece that we looked at was how energy access and electrification in rural areas can lead to a suite of different benefits on health and development side. And so we wanted to understand that a little bit better. So there's this key assumption and understanding that energy access brings benefits with it, benefits like increased income and education, some increased food and water security, additional livelihood options, and potentially health benefits, particularly around cooking. But we often don't understand under what circumstance these benefits are occurring, how the magnitude of these benefits change under different circumstances, which benefits occur under which circumstances, and what drives these differences. So there's a general sense that rural electrification increases household incomes, but the evidence is very inconsistent. So here's an example from China. There's a order of magnitude, the magnitude of the benefit is extremely variable. So this is an example of different provinces in China, and it's a 10 times to 20 times difference across these different regions, depending on how poverty is measured per unit money or per unit power. So extremely variable results there. And this inconsistency is showing up in the literature where people are really questioning whether this is really a solution, whether rural electrification will lead to the benefits that people expect. So we want to understand the circumstances better and explain the conflicting evidence. So our approach used, we wanted to unpack this relationship, and we did this by digging into kind of the causal pathways that underlie it. And this is a method that's in the Bridge Collaborative Practitioner's Guide. So trying to understand the causal pathways using logic models. And so we did a significant literature review on the different, trying to dig into these pathways and figure them out for environment, health, and development outcomes. We looked at over 2,000 articles, and about 500 of these were relevant. And so we mined these to better understand these relationships and what was happening under the surface. So many people have observed that electricity tends to be self-reinforcing. So if you've never had it before, you don't really know how to use it, and you don't take up electricity. But once it is in place and being used for productive purposes, demand tends to increase. You get increased incomes and increased notions of how to use electricity, so that self-reinforces. So our approach kind of to sketch out the mechanisms here and characterize the evidence and at these different steps and try to understand what's happening. So this is one such pathway, looking at crop yield enhanced by electrical pumps and irrigation. And we found that each of these links is very widely studied in the literature, top 10% of all links, of all of the links in our review. But no study addressed all of these links together, and there seemed to be a lack of knowledge about how to kick off this loop and get it started. So some questions about what the initiating factors were and what intervening factors affected whether this cycle took place or not. So just to dig a little further into some specific examples, so the literature often revealed that enhanced crop yields were, they were frequently cited by mechanisms related to pumps, and that increased income, then increased electricity use. But there were a lot of different factors that have come up as potentially leading to failures that were found in the literature. So these gray factors are examples of those potential intervening factors that caused issues. And I'm just going to give a few different cases. So one success story was well pole versus electric pumps in Bauchi State, Nigeria. So there were higher crop yields consistently and higher margins among electric pump users. In contrast, there's an example of rice in Mauritania. And there was a huge variability in the performance on the yields for rice, and they were well below the maximums expected given the amount of water and electricity there. And there were a bunch of different explanations given for this. Low quality water was used, there was a failure to apply fertilizer at the relevant times, poor weed management, and some of these factors are tied to kind of unexpected consequences, like the irrigation water was of lower quality, but others were just things that weren't considered in the strategy, things like the need for training on fertilizer and weed management, for example. And then there's another example that's an unintended consequences. They didn't expect this to happen, but it ended up being a good thing in the long run. In China, there was some cases where conversion energy access resulted in the conversion of forests to orchards. And this limited the supply of fuel wood, and so there needed more they needed to use the electricity that was put in place even more. So it created a positive feedback loop that increased efficiency in that case. So our overall observations are that electrification policy failures are frequently explained as a function of these overlooked factors. So these are not considered up front, they're just afterwards people say, oh, this might be why it didn't work. These overlooked factors are rarely controlled for in analysis of the overall relationship between electrification and income. And as a result, planning prioritization, other policy initiatives are rarely building on lessons learned in a systematic way because these issues aren't considered in a very systematic way. And so we're hoping that using this graphical modeling approach from the Ridge Collaborative can help us better understand those overlooked factors and pull them together. So there's no shortage of these retrospective explanations of why things aren't working in different cases, but it's not clear why people aren't considering all these factors in advance strategically. So what we're trying to do is to systematically qualitatively at this point understand all of these factors and how they fit together so we can set the stage for quantitative and more prospective studies. So we can hopefully help inform and do more predictive assessments of whether a policy and program will work in different places. So that's what the work has been done to date and will hopefully be helpful. So just quick acknowledgement, there were a lot of people involved, and of course the whole Bridge Collaborative is supportive of this, but I particularly want to point to Ryan Calder, who was the postdoc who did most of this work that I'm presenting today. Thank you.